Hi, everyone. Thank you for joining us for this KNIME training with the City of Milpitas. My name is Lauren Lai, and I'm the Finance Director for the City of Milpitas. I'm really pleased that we were approached by KNIME to collaborate and share our story and our use case. As I mentioned, my name is Lauren. I've been with the city for almost 3 years. It's a really innovative, diverse city. We're always looking at opportunities to leverage tools and look at how we can implement best practices to solve some of our challenges in governance. We're very fortunate to have talented individuals who think creatively and use what's available out there. And so these open source technologies are a great way for us to explore and pivot and apply in our current workplace. A little bit about our organization. As a city government, we are a full service city, which means we have the general police, fire, and utilities as well. Our systems that we have in place, primarily for our financial systems, we've had it for over 26 years, which means it has some immediate challenges relative to data access, functionalities, process, and procedures. And so when we develop something as complex as a budget, it's very difficult for us to access key critical information, to compile and make these critical documents for policymaking and resource allocations. So we've been able to use KNIME to bridge a lot of our various systems. And a little later in this presentation, our finance manager will be able to walk you through some of that and explain some of the improvements that we made. As the leader for the organization and the function of finance, I'm really pleased that we were able to explore this opportunity, pleased to share this with you, and hopefully it can resonate with some of your various applications in your workplace. So with that, I'll turn it over to the other speakers later this evening to share about the tool and also our case use. Feel free to reach out to us anytime. As I mentioned, I'm Lauren Lai, the Finance Director for the City of Milpitas. Thanks so much.
Hello, everyone. My name is Marco Mosciarello. I'm an account manager with KNIME, and today we are going to have a presentation about KNIME as a platform for everybody within an organization. So let me share my screen. Essentially, KNIME Analytics Platform is a tool for everybody within an organization. It doesn't really matter if you are a data analyst, a data engineer, and data scientist, but also an end user. You can really leverage KNIME to complete your data needs and to start working with data. So a quick agenda for this presentation. We will first an introduction to KNIME. What is KNIME all about? We will have a brief demo in which we will cover kind of the basics about KNIME, how you can start leveraging like the visual programming on KNIME to work with your data. And finally, we will close with some financial industry and public sector use cases. If there is any question, we can keep it at the end of the session. Just type it on the chat. So KNIME is a single platform for all the data users within an organization. We work with a lot of companies, both large organizations, small organizations, private, public. We see a lot of different types of data users, but we can primarily identify 3 types of data users. They are the data experts, the business and domain experts, and the end users. So let's focus on the data experts first. These are your data scientists, people that work regularly with data, and what they do is using data to solve complex problems, complex issues. Data scientists, of course, they know and they're knowledgeable of programming languages, but most of the time, they also know how to leverage no-code and low-code tools to create these solutions. Of course, a very scarce resource within organizations and not always available to solve maybe problems that are not as complex. To do so, there are like the business and domain experts. These are people that use data to leverage to essentially to making decision, and they are proficient in using maybe some programming language, maybe they're pretty good in using Excel, and they also have a good understanding of no-code, low-code tools. And what they really need is having fast insights access to insights, not only for them, but also for their teams. And in this category, we have several type of personas. We can have directors, we can have maybe managers that they want to create solutions for their teams and make reports available for their team. We also have data analysts and data engineers that they build solutions that maybe are not as complex as the one that the data scientists develop. And finally, we have the end users, which is the most common data user within an organization. This is a person that needs data to complete their day-to-day task. Maybe they need access to the insights every single day or once a month. But what they need is access to those reports to complete their job. And let's be honest, most of the time, these people, including myself, we have a good general understanding of Excel, maybe some understanding of a tool like KNIME, but we can still leverage these tools or the reports generated by these tools to complete our jobs. But why a solution that it's not programming like a program language is necessary to do data analysis? And the reason is because this is how data analysis looks with Python. Python is considered the easiest language available, programming language available, and still it looks pretty complex if you're not knowledgeable of programming languages. And this is how KNIME looks like. What you see here is a workflow. Essentially is a series of nodes connected together. And a nodes is essentially is this color square, and what it really does is perform an action on your data. It can be very different kind of actions, from reading to joining, partitioning, visualizing data, but also creating more complex stuff like training models. In this case, in the example, we have a decision tree model. And the beauty of it is that can really be used by everybody. And what you can do with it is from very simple ETL, so transforming and cleaning up a little bit of your Excel file, to creating very complex use cases like machine learning, predictive analytics, AI, etc. And the platform that you can use to create your workflows and to access the visual programming is the KNIME Analytics Platform. So let's focus on the left side of this slide. The KNIME Analytics Platform is the place where you can create your data lifecycle and create your workflows. You can blend and transform your data, you can visualize it, you can capture, optimize it, and really start to work and leverage your data in your day-to-day job. But sometimes large organizations, as well as like public or private organizations, doesn't really matter. They want to put their workflows and data into production. They want to be able to deploy their workflows, to validate them. They want to be able to share internally within their organization the results of their workflows. They also want to be able to monitor and update all the information that they are processing. And that's possible with the KNIME Business Hub. Now, these are not two separate solutions. These are part of the same KNIME solution. The KNIME Analytics Platform to create your workflows, and the KNIME Business Hub to put your workflows into production. There is an important difference here that we have to underline, is that the KNIME Analytics Platform, where you can create your workflows, is open source and available for free of charge from KNIME.com, and you can go tonight on the website and download it on your laptop. The KNIME Business Hub is the commercial offering on KNIME, which allows you to deploy your workflows, is cloud native, and unlocks also additional team collaboration features not present in the KNIME Analytics Platform. But for tonight, we're going to focus on the KNIME Analytics Platform. So a quick demonstration of how you can leverage on your day-to-day job. So let's assume that there is this scenario in which there is this Acme company that needs to analyze historical sales data. And we will see how we said historical sales data, but it can really be anything from supply chain to vendor management. It's really applicable to those areas as well. The goal here is to access sources, data sources from different data from different sources. In this case, will be an Excel file and a database. We want to do some transformation and manipulation of the data. And the final goal is to create a visual dashboard as well as a CSV report. So now let's start and sharing the KNIME Analytics Platform. We already created the workflows, and we are going to cover some of the steps that we use to create this workflow. So this company had traditionally until 2022 used to record all their sales data on an Excel file. After 2022, they started to modernize a little bit, and they started saving all their sales data in a database. What they want to do now is to clean up the data first, and then have a single table from which they can generate a report that includes all the information that are both from the Excel file as well as the database. So the first thing that we want to do is to be able to open and work on the data in the Excel file, for example. And what we do here is just selecting the Excel reader, which is the node that we use to read Excel file. And for almost every action that you want to run on KNIME, my suggestion is just almost verbalize it. If you want to search for a node that does a specific action, just saying, I want to read an Excel file, just search for Excel, and the first node that appears is Excel reader. At this point, you can just drag and drop it into the canvas and search and upload your Excel file. Doesn't really matter where it is. It can be like cloud on your laptop, doesn't matter. In this case, we already read our table, our file. Now, this is in a table that we can be read through KNIME. And we see here that we have several different information, like data. We have a customer ID, first name, last name, age, city, country, etc. Great. Now we know that most likely there are some mistakes on this Excel file because it was all the information here were input manually. First thing that we want to do is to eliminate possible duplicates, essentially rows that have the same exact information that are going to kind of ruin our report at the end. So again, if I want to remove duplicates from my table, the thing that I would do is search for duplicates in the search bar on the left side, find the duplicate row filter, which is the first node that appears, and just drag and drop it in the canvas. We already connected here, and we executed this node. As you can see here, we started with 2,848 rows. And after we remove all the duplicates, we have 2,374. So there were a lot of duplicates in our Excel file that we kind of eliminated them. Now, I'm not going through all the single nodes that we use here, but there are very diverse tasks that you can do. We can remove rows with missing values, and again, search just for the missing value nodes. Numeric outliers, for example, there is someone that the age is minus, we already removed it, but like minus 5,000 years old, which of course is a mistake and is going to skew all our numbers in our report if we have that number included. So we're able to use a node to remove also outliers. Finally, we change some numbers into string because we want to clean up and change a little bit the format of our table. And now we're done cleaning up our Excel file. What we want to do now is to concatenate this clean Excel file data with the data that we have in the database. First of all, we have to connect KNIME to the database. And that's very simple, can be done with almost every time with just 3 nodes. The first one to connect KNIME to the database, the second one to select the table on the database that we want to use, and the third one to read the table in the database. We do some cleaning, profiling, and transforming, or also in this case, let's assume that we are done. Now we want to concatenate and have a single table that includes all the data from the Excel file that we clean up, as well as from the database table that we cleaned up. And we can use the concatenate table to do so, the concatenate node. And as you can see here, we have 3,880 rows, and they come 2,298 from the Excel file that we cleaned up, and 1,582 from the database that we cleaned up. Great. Now we have exactly what we wanted at the beginning, but we also realized that we have a separate file that have some information that are common to the previous tables, but also some additional informations that can be useful and we want to add to our report. For example, we have the customer ID that was present also in the previous tables, but we also have additional information like the date, where a specific purchase was made, the store type, like online or on-site, and the price of how much the purchase was for. So we can use KNIME to say, hey, if this table, if the customer ID in this table matches the customer ID in the previous table, just add all the information to that specific customer ID. And we can do that with the joiner node. So essentially, we're saying if in both columns, in customer ID columns in both tables, we have the same customer ID, add the data to a single view. And what we have here, after we run the workflow, it's a table that includes not only the customer ID, the name, the age, the city, country, email, etc., but we also have specific ID like the date, store type, price, and all the other information. So we were able to connect and join two different tables with different information to have a more specific and complete table with all informations we need. So now it's time to create the report and visualize the data. I'm not going through tonight how you can create and use all the visualization nodes that are KNIME, but it's important to know that KNIME has visualization features directly already present in the tool itself. You can, of course, still connect to different type of visual reporting tools, but KNIME already has some pretty good tools, features inside the platform itself. We are going to see what's the final results of these nodes. And this is the dashboard that we created for as kind of result of the specific workflow that we created. These are customer transaction analysis based on age that we can run and refresh changing the age range. So for example, in this case, in these pie charts, we see how in the city of San Jose, 17.33% of our sales volume was from the city of San Jose. But if I change the age range and I rerun in the background the workflow that we just created with this different age range, we see how the sales volume in the city of San Jose actually changed and is now only 12.95%. Of course, the pie charts are not the only charts or visualization features that you can use. There are so many. We selected just a few here. For example, like a box chart. Here is a heat map. This is also interactive. A line chart in which we kind of analyze the gross sales volume based on the month. And finally, we also included the possibility to download a CSV file with the table that we created. So we can just simply download it on our laptop and we can open it. And now it's ready to go. It's a CSV file that we can download and share with the rest of our team. Now, this is how probably like the domain experts and the end users can leverage how to use KNIME. But as we said, also data scientists are kind of personas that can leverage KNIME in addition maybe to programming languages. And as an example, I'm probably not the best person since I'm not a data scientist to talk about this, but in terms like this is a workflow that has inventory management and demand forecast for one of our customers. And this workflow has hundreds of nodes connected together. And of course, as you can imagine, there is a lot of predictive analytics because they have to predict how much they're going to sell to their customers and how much they have to stock in there as their inventory at the same time. So they have to predict based on historical values. And this workflow is enormous, has a lot of nodes together. And this company chose to use KNIME instead of programming language to do so. Finally, I want to just close this kind of KNIME quick demo with the latest feature that we developed for KNIME, which is the KNIME AI, which we call Kai. Has two ways to use it. One is a question and answers, in which you can essentially ask a question to Kai and Kai gives you an answer. And the second one is building a workflow just with a prompt that you can ask. In this case, I asked Kai, how do I remove duplicates and join tables? And Kai replies saying you have to use these two nodes, like the duplicate row filter and the joiner filter. But my favorite feature is the build feature. In this case, you just need to select a file. I selected the same one. I did it previously, the same one that I generated from the workflow that we just ran a moment ago. We select it, we run it, and I can tell Kai remove rows with San Jose, and now Kai is going to think about it for a moment. Unfortunately, connection is a little slow, and is going to generate, like saying, okay, you need to filter out with San Jose with a row filter node. We run it, and now we're going to ask Kai to create a pie chart with the sales per each city. And again, Kai is going to think about it for a moment and is going to start generating the workflow automatically without me doing anything. First, use a group by to group the data by city and sum the price for each city. And we're going to run this. And in a moment. And then use this visualization node to create the chart. And without me doing anything, Kai created this pie chart out of just a couple of prompts on the Kai Assistant side. Okay, just to close this presentation, we access data from different sources. We transform it, and we join data from different table, and finally we visualize the data and create a report. And to close the presentation, a few use cases both in the financial industry as well as public sector. We have a lot of companies working and using KNIME both in Europe as well as in the US. For example, two large European banks like ING and Rabobank, they use KNIME for pretty complex use cases. ING use it to do data mining on their own internal audits to kind of improve how they do it and what they can find out during the audits. Rabobank actually uses KNIME machine learning to identify money laundering schemes using machine learning. In the US, instead, for example, we work in North America with Fidelity and a lot of very large banks, which we cannot name, but they use it from spreadsheet automation, ETL, as well as regulatory reporting. They can automate instead of running everything manually. But we also work with public sector entities, both in Europe and in the US. For example, in the US, we work with the FDA, the Food and Drug Administration, and also the Anti-Terrorist Task Force, or whatever it's called, for a very analytics to detect gray zone activity. I don't really know what it means, but pretty complex use cases as well. And this is the end of my presentation. If there is any question, I don't think so. I think we can move forward with the next presentation.
Well, hi, everyone. Thank you for joining us. My name is Fanny Lay. I'm a finance manager with the city of Milpitas. I've been here for almost 4 years. So tonight's presentation, I'm going to talk about leveraging KNIME data transformation to bridge legacy ERP system with modern reporting demands.
We will go through use case, a little bit background about the city, the ERP system that we currently use. Then we'll walk through the partial workflow of the use case, and then we will end with Q&A. So what's our use case? A little bit about our city and also the ERP system we currently use. So the city is currently relying on a legacy system that has been in use for about 26 plus years. As you can imagine, as reporting demands has modernized, the system really hasn't kept up with that challenge. It lacks the customization needed to fulfill various modern reporting demands. As a result, staff must invest significant time in manually manipulating exported data to meet the formatting requirements for different reports. So our use case we're going to talk about tonight, we have created different types of workflows for different scenarios. Tonight we'll focus on one specific use case. So as Lauren mentioned, budgeting is a huge project that we take on every year, and the projection of workforce cost is especially important and critical to that process. It involves uploading a structured spreadsheet, a flat file to OpenGov, which is the platform that we use to do our budgeting. The spreadsheet encompassed details such as employee names, titles, position attributes like salaries, mandated increases, step increases, PERS, medical, health benefits, and other benefits. Basically, any cost that could be tied to a position. And the reason we need to capture all the costs is so that we have an accurate picture of how much these positions will cost the city. The compilation of this information was always a manual process, requiring the assembly of data from various reports exported from legacy ERP system. As you can imagine, it was very time consuming, and staff dedicated a minimum of 2 weeks to gather all the necessary information to create the flat file for upload. So next we'll talk about the workflow that we created to bridge the gap. So this is kind of a partial view of the workflow because the workflow itself is just too large to capture. We'll start with the left side. So what we do first is we have a Oracle connector, and this is how we connect directly to the database in the back end. After we make this connection to our database, we're able to use DB query reader nodes to extract information from different tables, because now we have access to all the tables that's stored in the database. So as you can see, we have different data streams. So we'll go from bottom to the top. So at the very bottom, we have two data streams coming together in a joiner. This is extracting salary data from payroll tables. And this is especially important because we need to capture the pay rates for current employees. As we move up, we get to the medical deductions. So this is where we capture information for staff that have healthcare selections. Either it's single or could be family and other options, and also dental and vision. So that's also a huge part and component of our cost. And then we'll move to the data stream above that. That's the fund distribution. So for us, and I imagine other organizations as well, the position is often split between different funds. And it's important to capture that information to do an accurate projection for the budget. And before automating it, it used to be done manually, which is very time consuming, as you can imagine. The top data stream is supplemental earning codes. So these are for staff individuals that have supplemental earning. And so we need to capture that in the overall cost of the position as well. So this is how we have really utilized KNIME to extract information and combine them in a meaningful way using various nodes, either column expression, to do calculations. We do joiner, so we can identify the primary ID for a table and find a common ID between tables, and then we can join that information together. We also have different things like a rule-based row filter to filter out information that is valid for this calculation, and different ways. And it's always fun to play with the different nodes and figure out what you want it to do. And sometimes it's really going around the node to get the function that you need. And then we'll focus on the data stream at the very bottom because it's the most critical. As we move to the right side, that section right there is calculating the current salary steps for these people. So we need to figure out the salary step so that we can connect people's pay step to the salary table that's in OpenGov, our platform for budgeting. And then after we figure out the current salary step, we then use Python to actually project out the beginning salary step for the new fiscal year for each individual. And that used to be done manually. So we have about 450 employees. We would have to do that row by row. That would be incredibly difficult. So moving on to the next slide, this is very similar to kind of to what Marco presented. So it's kind of the reverse. We actually use this in together in conjunction with KNIME, not to sort of be replaced by KNIME, by using it together, sort of synergy, which is really the most powerful part about KNIME, I think, is because you can have low code, no code situations, but you can also have the capability and capacity to have more complex calculations and incorporating Python in here if necessary. So just quickly going over these codes, it's very simple. All we're trying to do is we're trying to figure out if employee A is step A right now, what will their step be in the new fiscal year, say July 1st, 2025. So how do we go about that, right? Basically, we have 3 columns in the data table that we created before this script. We have 3 columns that tell us either this employee was promoted of a certain date, hired a certain date, or they received a merit increase at a certain date. So then we use different prioritization techniques. We read in the table, we import some modules in there. We create different functions in here that then, as you can see, we first test out which column is empty, right? So the if, and then we see the kind of like the indentation there. So the first paragraph is reading like if the current position date is none, so there's no data in that, then we go to the next, right? So then we check merit increase because that's really the hierarchy of a person's date. So the promotion date outweighs the other 2. Merit increase outweighs the higher date, and higher date has the lowest priority, if that makes sense. Because if this person was promoted during the year, then the promotion date takes precedence over the other 2, and that resets the count, so to speak. So that's what you see here. So we check the current position date, which is the promotion date. Then we check the merit date. And then this is what we return. So that's the function we're trying to do. So then we're trying to figure out divide by 30, divide by 12, because we're trying to find the year of this person. So, and then the elif, so that's another one. It's another exception to that. So if the increase date, so if the merit increase is not none, so it's not empty, and this is what we do. So it's kind of a if you use Excel, it's kind of like the if nested formula, very similar to that. The only difference here is that and this could have been done in a node, really, in a column expression, but what Python brings to the table that's not available in the node is we can actually alphabetically add the steps. So for example, if the year returns to like a 2 or a 1, I can say that A plus 1 equals B, but that cannot be done in a node that I'm aware of anyways. So in Python, you can do that. You can dictate the character and the function to be alphabetical and the function to be that A plus 1 equals B, and then so on and so forth. So then in the end, we have new steps for these people projected. First, we test it out to see if it's equal to the top step. If it is, then just the top step, because we don't want to go beyond that boundary. And then if it's not, then we go with the new step. And now we create a new column, which is called the new step column. And that's what this whole thing is doing. Before this, it was done manually. It was very difficult. But with this, it's very easy. That's my presentation. And any questions? And a little distribution joke for data fans. Our information is on there. As Lauren mentioned, if you have any questions or interest in using this tool, please reach out to us.